Okay, let's have a look. We've got this point 3 minus 2, that's important. We've got a curve with this equation, and it's going to be mapped. So we know this is inside the bracket, which impacts the x coordinate, so you plus 2 to the x value. So that's all we're doing, is to plus 2 to the x value from 3. And so that will be our new coordinate mapped under the transformation. Part 2. Now remember, we're solving for this, so what's the inverse of times 2? It's a half x, so the transformation is affecting the x coordinate by timesing it by a half or dividing by 2. So we just half this coordinate 3 to make it 1.5. Now the very last one, if it's outside, that means we're plusing 5 to the y coordinate. This is outside the bracket and this is affecting the function, so we're multiplying the y coordinate by 3. So we're multiplying the y coordinate by 3 first, then adding 5, like laws of BIDMAS. Okay, now we've got the x as a negative sign, so all it is your x coordinate changes sign to minus 3, and if you think you're starting at minus 2, you're timesing that by 3, which is minus 6, and you're adding 5, so you get minus 1. So here's a question for you to try, question 2, just applying the same rules. Press pause, give the video a go. Press pause, give the question a go, and then I'm going to go through these answers. So inside, opposite impacts x, so we minus the x coordinate by 3 and then minus the y coordinate by 2. Okay, so this is what our new coordinate would be. Part 2, we're multiplying the x coordinate by 3. Part 3, like before, using the same skill, multiplying the y coordinate by 3, then adding 5, and the x, is because it's negative, it changes sign. The very last one is outside the bracket affecting the y, so the y coordinate changes to a negative, and the x coordinate is minusing by 2 from the original coordinate, and that's straightforward. Well done, you got that right. Okay, let's have a look at this question now. You can see that it is a function with a divide, so that we must use the quotient rule, which is in the formula booklet. Do make your v's and the u's clear so you don't get mixed up. Now it says show that the differentiation of f of x equals ax squared plus bx plus c to the x squared plus 4 squared, where a, b and c are constants to be found. You can get full marks on this. I believe it is worth 3 marks. So label your v and u. Remember your v comes first, so now do your du dx and your dv dx. Okay, now substitute this into your formula correctly. So remember, it's v first, then multiplied by u. Don't forget the minus sign, and that's your u times your dv dx here. Okay, all over v squared. So substitute correctly, that's 3 out of 3 marks. Next stage is to simplify the top, so multiply out the brackets. Once you multiply out the brackets, do be careful of the negative signs, because that would give you 2x squared plus 8, which is here. Now that will give you minus 4x squared because you've got the 2x on the outside. Remember, minus times a minus gives you a plus 6x. Simplify to get this line, and obviously the function is in terms of f of x, so do write f prime x, and you can see a equals minus 2, b equals 6, and c equals 8, and that is an easy 3 out of 3 marks. Part B says, hence using algebra, find the values of x for which f is decreasing. You must show each step in your working. Now, that's quite straightforward. If it's decreasing, then the gradient function, which is what dy dx is less than 0 for when it's a decreasing function, or the range that it is in decreasing, right? So, set up an equation like so, and I know you get stuck here, but if we multiply out by the denominator here, which is multiplying both sides like so, by these, then that cancels out because 0 times anything is 0, and we get something quite nice here. Now we're multiplying both sides by minus 1, or you could bring everything over to the other side. Remember, when we multiply an inequality by minus 1, the sign flips, so the sign changes. I want to deal with an easier quadratic to factorise, so I can divide this by 2. Now remember, your calculator does do all of this, so you shouldn't be making a mistake. So we can set that to 0 and just remember our range of values. Look at our range of values where it's greater than 0. So we've got x equals minus 1 and x equals 4 are almost like critical values. You can see the highlighted areas are here, so it's going this way and this way, so it is split, so it's when x is less than minus 1 and x is greater than 4, and I think that's another 3 out of 3 marks. Well done. Here's a question for you to try on your own, just to make sure you get that skill. Part B, find the equation of the tangent to C at the point where x equals pi over 2. So remember to put your calculator in radians. These questions can appear in different contexts, so it's worth the skill. Can you get this right? Pause the video, give it a go. Right, I'm going to give you the solution. Set up your u and v. Do your du dx and your dv dx. Using your quotient rule here. Be very careful, making sure you have v first times the u dx, then it's u times the v dx over v squared. Okay, now I've underlined this section for a reason, because remember, cos squared x plus sine squared x equals 1, so we have 2 lots of that. That's going to become 2. Okay, so that allows us to simplify the term at the top to get what we're looking for in the show that question, and that's a 4 out of 4 marks. Nicely done. For part B, x equals pi over 2. So we need our y coordinate as well, because we're doing something in the form of y equals ax plus b. So we substitute this into our original y formula above, which gives us pi, because pi over 2 times the 2 here gives us pi. So at pi over 2, your y coordinate is 3. Now remember, our gradient function is here, so we substitute our pi over 2 to find the gradient at this point, and that gives us minus 2. So you can use y equals mx plus c, or this formula, y minus y1 equals mx minus x1. Whatever you prefer, but I'm going to use this method because this is what my class tends to use more often and comfortable with. Substitute your found coordinates in and rearrange to find C and write the equation in the desired form. That's it, another 4 out of 4 marks. If you got that, well done. Excellent work. Okay, let's look at the keywords. We've got a graph in figure 3. It's a path of a small ball. The ball is thrown from point represented by A. That's at 0, 2. This has got to be relevant information. This has to be used at some point. It's represented by B. So this is a graph H against X. So instead of Y, we have a H here. Now we've got the height H meters of the ball above the ground. It's been plotted against the horizontal distance where it was thrown. So, for example, it could be thrown by a person who's 2 meters tall, representing the Y. Now, we have this information. The key bit of information is the ball reaches its maximum height when X equals 9, right? So we know that this is some type of negative quadratic, but all quadratics are sort of in this form, but we know it's a negative one. Using our point X equals 9, we know that this must be a solution with a possible constant of K, or you can give this any other letter you want. And it could have a plus or minus C for the y-intercept, possibly, or another constant. So the max height is at X equals 9. So we know that when X equals 9, we get a maximum. That's for completing the square. Now, if we use our point A, so when X equals 0, H equals 2, we can substitute this into the equation we've just made here. So let's do that now. So we're at 2, X is 0, so we're going to get minus 81k plus C, only because I know this becomes positive, but we have a minus k here because we know the quadratic is negative. And that C could be plus or minus. Let's just leave it like this. What else do we know? We have B equals 20. That's your X equals 20, H equals 0.8 as well. So we can substitute that into our equation, call that equation 2, and create another equation. Now, that allows us to find K. We also know that when X equals 0, Y equals 2, H equals 2, which we made the equation above. So this makes a simultaneous equation. So we can do equation 1 minus equation 2. Okay, so 1 minus 2, so 2 minus 0.8 equals 1.2. Be good with your negative numbers. Minus 81k minus 121k, it makes it a plus, so that's 40k. And because we're minusing, we can cancel the C's. That's what we want to do, so we're left with one unknown. You could match the K's and work out that first, but it's easier to obviously cancel out the C's straight away. So then we get K equals 0.03. We know there's a minus sign in front of the K, so we can sub that back into our equation 1 to find out C, or any equation. Work out what our C is. C equals 4.43. Now sub that into what we've made at the top, and we've got 4 out of 4 marks right now. Once you get shown this, you can use this technique for any type of question. Now, what's the next term? Give a limitation, one limitation of the model. There's lots of different limitations. Any of these would get you a mark. I like to just use air resistance, not factored into model. That's fine. That's your 1 mark. And you can get that without knowing any of part A or C. Now Chandra is standing directly under the path of the ball at 16 meters horizontally, so that's at X. Can she catch the ball if it's less than 2.5 meters above the ground? Use the model to determine if Chandra can catch the ball. So you need to sub X equals 16 into your model so that we can find out what the height will be at X equals 16. So that's where Chandra is standing. We get height, H equals 2.96, so obviously that is greater than 2.5. So Chandra cannot catch the ball. Hopefully you can try this again in the future and get 7 out of 7. Now here's one for you to try. Pause the video and give it a go. It's out of 6 marks. Right, I'm going to go through this. Right, so let's have a look at this question. We have a similar type question, but we've got to apply our skills. What's the key bits of information here? X equals 40, it hits the ground at the point 40 meters. We can see it also starts at 0 at X equals 0. So a key bit we need to know is the maximum point is going to be when X equals 20, and when X equals 20 the ball reaches a height of 12. So let's think, if this was a normal quadratic, it'll be in the form of X bracket X minus 40, because that's when Y equals 0. Okay, but we could have an unknown constant here. Now we're going to write it as 40 minus X because we know this is a negative quadratic, so minus X times X is going to give us that minus X squared that we want. And there could be a value here, that a constant here, A, so we put that in, but we can work it out. So you can see your solutions are X equals 0 for when Y equals 0, or H equals 0 in this case, and 40. That's how we start that off. So we can use this information we have here and sub it into our formula, and because we only have one unknown, which is A in this case, because we know H and X, we can sub that in and solve. Straight away expand, rearrange and solve for A, like so. So A equals 3 over 100, rewrite the formula, we are done. 3 out of 3 marks. Probably the easiest way to do this question. At part B, same skill, it's just a bit of application. Right, the ball passes over a horizontal bar of a set of rugby posts that is perpendicular to the path of the ball. The bar is 3 meters above the ground. Use the equation to find the greatest horizontal distance of the bar from 0. So we just substitute H into 3 into the equation we've made. We can rearrange it and solve for X. Now think about it, the bar 3 meters can be here and here, so we are going to get a quadratic with 2 values, for example. Could be here at 3 meters and here at 3 meters. So expand, make a quadratic, rearrange and solve. It says the greatest distance because this will be our answer. Now the 20 minus root 300 is obviously going to be right here, but it says greatest value, so we use our 20 plus root 300 answer, and that is quite easily done. Well done if you got that right. Do revisit these videos in a few weeks to make sure you can remember how to do it, because you forget 20% of what you've learnt after a day, which is the research of an average person's retention.